Today we're going to go more in depth with the probability piece of it, and it does get more difficult today. It says 5 fair coins are tossed. Find the probability of the coins showing at least 4 heads. Well, if I'm tossing 5 coins and I want at least 4 heads, that means I could get 4 or 5 heads. So I want to find the probability of getting 4 or 5 heads. I'm going to start with the probability of 4. I'm tossing 5 coins all together. I want 4 of them to be heads. The probability that I get the heads is 1/2. And I want 4 coins to have a heads. The probabilities that I flip tails is 1/2. And I want 1 of them to be a tail. That's for the probability of 4. Now for the probability of 5, I'm going to do plus for the or. Probability of 5, I still have 5 coins and I'm choosing 5 of them to be heads. The probability that I flip a heads is 1/2 and I want 5 of them. The probability that I do not flip a heads, that I flip a tails, is 1/2 and I want 0 of them. Type it in your calculator. You can type it all at once. Just be very careful. If you need to, pause the video because I don't want to waste too much time here. But what you'll do is you'll get a decimal. Please change it to a fraction. The fraction will be 6 out of 32, which you have it probably reduced as 3/16. At least 3 heads means you could have 3 or 4 or 5 heads. For the probability of 3, it will be 5, choose 3. The probability of flipping a heads is 1/2. You want 3 of them. The probability of flipping a tails is 1/2. You want 2 of them. Plus, and then look, you have the probability of 4 or 5, but you just did that. That is equal to 3/16. So instead of writing it all over again, just say plus 3/16 afterwards. So you end up getting 0.5, which is 1/2. At least 2 heads means you could get 2 or 3 or 4 or 5. So for the 2, it will be 5, choose 2 of them. Probability of a heads is 1/2. Probability of tails is 1/2. You want 2 heads and 3 tails. Plus, the probability of 3, 4, or 5 is left, which you already did, is 1/2. You guys type it in and finish that one. Also do the one with at least 1 head. You guys will try that one as well. A spinner is divided into 6 equal sections, numbered 1 through 6. The arrow is equally likely to land anywhere on the section. So if I were to just draw a little picture of it off to the side. Oops, that's a bad picture. One, 2, 3, 4, 5, 6. Not much better, but you see I have 6 sections. They should be equal. Find the probability that I spin a 2. Well, the probability that I spin a 2 on anything is 1/6. At least 3 2s on 4 spins. So at least 3 2s mean I could have 3 or 4 2s. If I am spinning 4 times, to find the probability of 3, it'll be 4, choose 3. The probability that I spin a 2 is 1/6, and I want 3 of them. The probability that I do not spin a 2 is 5 out of 6, and I want 1 of them. Plus 4, choose 4 for the probability of 4. The probability that I spin a 2 is 1/6, and I want 4 of them. The probability that I spin a not a 2 is 5/6, and I want 0 of them. Take the time to type it in your calculator. You will get a decimal, but it is 7 out of 432. At most 2 2s on 4 spins. At most 2 2s means that you would have 0 or 1 or 2 2s. If it's at most, that means 2 or less. So the probability of 0 would be 4 choose 0. Probability of spinning a 2 is a 6th. You want 0 of them. Probability of not spinning a 2 is 5/6. You want 4 of them. Plus, the probability of 1 is 4 choose 1 times 1/6 to the 0 times 4/6 to the first. 1/6 to the first for 1 2, and 5/6 to the third for 3 not 2s. Plus 4 choose 2 times 1/6 squared times 5/6 squared. Type that in your calculator, see what you can get. Also, you guys are going to do the fourth one in that section to try. Moving on. A quality control department tests a product and finds that the probability of a defective part is 0.001. What is the probability that of a run of 100 items, no more than 2 are defective? And exactly 2 are defective. So no more than 2 first. That means 2 or less. So we're trying to find the probability of 0, 1, or 2. You're running 100 items. We first want 0 of them to be defective. The probability that it is defective is 0.001. You want 0 of them. Probability that it's not defective is 0.999, and you want 100 of them. Plus 100 choose 1 times 0.001, this time to the first, times 0.999 to the 99th. Notice what's in my parentheses doesn't change. And finally, 100 choose 2 times 0.001 to the second times 0.999 to the 98th. Type it in your calculator, round to 4 decimal places. You will get 0.9998. And finally, exactly 2 is the other part of this question. It's the probability of 2. You have 100 items. You want to choose 2 of them to be defective. The probability it's defective is 0.001. The probability that it's not defective is 0.999. You want 98 of them to not be defective. Type that piece in your calculator, you get 0.0045. That's just a straight mark. And this question here was on the Regents exam. A study finds that 80% of local high school students text while doing homework. 10 students are selected at random from a high school. Which expression will be part of the process, only part of the process, used to determine probability of at most 7 of the 10 students text while doing homework? Well, at most 7 would be the probability of 0, 1, 2, 3, 4, 5, 6, or 7. Now, yes, you could list them all out if you wanted to. I'm not going to spend the time to do it. I'll do the first one so you can see what it would be like. You would have 10 students all together. We would choose 0 of them to be texting. The probability that they text is 80%. So that's 4 out of 5. Okay, 0.8, 80% is 0.8, as a fraction is 4 out of 5. And you want 0 of them to do it. And then the probability that they don't text is 1/5, and you want 10 of them to not text. If we're doing at most 7, please take a look at this. There's 2 of them I can cross off right away. C and D, because they have the 8 and the 9 in it. So I am between The first and the second one. Think about how this setup would continue. Would it be more like the first or more like the second? You decide from there.